Good afternoon, all, and welcome to the UAS Cluster Initiatives Lab to Business Technology presentation. This is the third in our series for this operating year that the cluster has, which ends on September 30th here. And so, for I guess to start here, I'm going to introduce Craig Mahaney, the Executive Director.
Oh, thanks, Jack. Yeah, welcome everybody. Jack already mentioned it, but well, first off, hi everybody. I'm Craig Mahaney. I'm the Executive Director for the UAS Cluster Initiative. And so I just wanted to kind of come on before we got started, just for those that haven't joined this before or haven't met before. The UAS Cluster Initiative is a SBA funded regional innovation cluster focused mostly in the state of Oklahoma, but we also partner with some regional folks in some of the surrounding states, depending on the deliverable we're working on. But we're really focused on the unmanned aerial systems and advanced air mobility sort of niche part of the aerospace ecosystem. And yeah, so a couple different things we do. We focus on access to capital for startups, and then also mentoring of startups specific to the industry. We do some demo days to help connect technologies with industries to kind of see how they could partner and get some business flowing in their direction. One of the things we also have a pretty heavy focus in is, and where Jack comes in to help us out, is technology licensing and transfer. So we do these pitch sessions after Jack spends some time scouring different university and federal labs to find technologies that are interesting to this ecosystem and that we can share with folks that either have a current business that may want to find a technology that they can plug and play, or if it's an entrepreneur looking for a business that they can start with one of these technologies. So yeah, that's a little bit what we do. And also wanted to say there's a lot of exciting things going on just in our kind of regional ecosystem. We have it was recently announced that the Tulsa region had won the Build Back Better Regional Challenge Phase 2 grant focused on advanced mobility, and that is a $39 million award, and it is focused on really a partnership between Osage Nation, Oklahoma State University, and Tulsa, City of Tulsa, to do a BVLOS flight test corridor, and then also an R&D launch pad facility around Tulsa. So lots of exciting things going on, which is kind of dovetails into the technologies that Jack's going to present today. And so with that, I will throw it back over to Jack. And Jack, I don't know if you know it, but you're not showing the slides anymore. So
yeah, I jumped off because I wanted to make sure to admit anybody else that was trying to get in here.
All right, back to you.
And let me see. This is the one. There we go. So, as it said, welcome to the presentation today. We have 4 technologies. We'll talk about them. The first 2 are very interesting. They're out of NASA Ames. We don't have any, because they all had conflicts and other things. We don't have anybody from representing the labs today, but if you have any questions, we can get them down and send them back to you. So the first 2, one is on vertiport assessment, mobility operations, and the other one is the other one from Ames we'll talk about in a minute is on UTM, Unmanned Aerial System traffic management. If you're not familiar with NASA Ames, and you probably are if you're in the UAV space, because they're very, very active. They have a lot of researchers in their group, and they are leading a lot of the research. They're working very, very heavily with the FAA and a number of groups around, and they treat these technologies as very robust from a systems engineering standpoint. So they gather a lot of the different dimensions of things that are going on, and they put them together in a software package or with the appropriate algorithms and all to work through that. So I gotta get rid of that thing here. So basically, what this vertiport, they call it, nicknamed it VAMOS, which is kind of nice. It's easier to say. It's a NASA developed tool based on advanced air mobility, their campaign and research projects. A lot of the factors they look into this for this vertiport assessment are things that they have validated or have done some research on what characteristics, even down to public opinion type things, like they discover people are kind of adamantly against putting these things around schools. But anyway, this you can pick an area, or you can kind of set up a your zones, and it helps you find or assess ones that you've identified, which is a vertiport location within a network, and based on a number of key factors, along with what city goals, what objectives, also what type of industry or services are going to be going on in and out of that vertiport. Is it going to be transportation, or is it going to be delivery or other things that are going like that? So kind of the problem, so on both of these, this is kind of a train. The light at the end of the tunnel is a train for a lot of the cities, because as people are developing a lot of these vehicles, and as they come online, this traffic's going to increase, and there's going to be a demand for it. And so if cities want to maintain a competitive business environment as it goes through, they're going to need to go look at how they're going to plan around these type of things, including all the different applications, from first responders to services, public transportation inspection, things like that. They can adapt to the variable designs, and trying to build up. Their goal when in developing this thing is that the infrastructure should be ready as the new vehicles get certified and come online and approved for operation. The other thing in here, it also looks at this as a network, because you may have multiple network with channels and streams going through the metropolitan area, depending on what's going on, and those characteristics may change. So you really need a tool to start looking at these things, because there's going to be a number of rules and policies and things that you need to consider, and this is going to be new. And I think we'll talk about it here in a little bit. This is kind of a neat opportunity for some folks, because even though there's Ames and the FAA and some other groups are studying these heavily, and they're studying them in cities like LA and Dallas, this is going to have to be spread into other towns too. And so a lot of these cities are not going to really have a good understanding of all the factors they need to consider. So kind of as I'll lead to, thinking about it almost as a consultancy type service that you build into, maybe where the opportunity is. So for this technology and the next one, for the charts we're going to do won't necessarily do them justice, and I'll come back to this, is the fact that if you really are interested, you should contact the lab and get a demo there, because they have a lot of capability in them. But anyway, it's a software planning decision support tool, and you can identify where the geographic locations are suitable, and it scores them on the suitability of those locations, and it can evaluate those locations along with the local subregions. So meaning that if you have a network of them, it can say how suitable is it playing into this network of vertiports, across a city like LA or Houston or Dallas or something like that, where you may have a number of them. The factors including zoning, land use, what transit stations. So part of that's going to go in there. You may want to put it next to a bus station or a rail station. If you need it next to fire stations, you also consider things like noise, congestion, time varying. Do you need to have them? How are they going to be around like stadiums if you are in some of these places and you have games and things like that where 80, 90,000 people are converging on an area. Some of that's going to be this traffic, but it also is going to affect how you do this traffic. So that allows a lot of customization, assessment, and evaluation of that. And it provides some location suggestions, and risk assessment. It can even do kind of the economic analysis depending on what type of traffic you have going through there, and some offers for structural design and the feasibility. And in this system, it allows you to model some of that and that dynamics that goes through there, which is what you need to do for that. As we've been saying, some of the city planners are going to need a better understanding of how advanced air mobility and vertiports. There's a few prototype cities, but those are being used to try as learning examples. And that's the nice thing is the NASA Ames people and an FAA and everything else have these as projects, and they are working to learn things by trying to understand how they would be applied in the city, and what factors need to be included and things like that. So it's a new thing, it's a complicated thing, but they're also providing kind of a knowledge base for all of that. As I said, it can be, if you're looking at it as a business type thing, it could be consultancy or planning or, ongoing operations, depending on where it is. You can kind of also look at, UAV, UAS type things, are on their own trajectory, and there's new things that are coming in as capabilities are coming in with batteries and stuff like that. So it offers a capability to help that. The other interesting thing I think is kind of good here, if you're part of this, in one way, you're a little bit at the table. It's a unique view of urban planning, so you can see where other people are, planning and needing to do things in businesses. And so you can be part of those opportunities. It's kind of like the real estate developers were always, we're interested in where the freeways are going to begin with, right? Because that's where they kind of focused resources. So this one, and normally we don't do this, but it's got so much research behind it is there, but it does not have an issued patent at this point. There's a patent filed. It's very active research area. So normally we wait for something that's a patent issued, but we kind of trade that off, or at least I trade that off on what's the potential for it. And there's a lot of interesting potential on this. You can collaborate with this group, and they are laying down a nice trail. I will put some links, and you can find a lot of the research papers out there. If you go to the website, you'll and search for NASA AAM, you'll find some of those links and things like that. There's also a NASA STI, which is scientific and technical information website. So most everything that gets published by NASA ends up in there. So you can go look at the papers and stuff like that. And so, as I said, it's working in a couple prototype cities. The development requirements, it's nice because they're putting this thing together rather robustly and from a system engineering point of view. And so you can, if you go back through some of these links, you'll see where they've had several phases where people are, contributing inputs to the requirements and their thoughts and things like that. And they're doing let's see, research on a lot of factors that they're there, and including the user interface. And so if you are interested in that, I've got a couple links here. Jay is the one at NASA Ames Research Center for more probably technology questions. If you want to get into the licensing support, Corey is actually can get in there and help you fill out the link, the license on that. Having said that, any questions? Yeah, we will post this video and these slides on the website, the new website, in a few days. And I'll send an email out to everybody who's registered here to let them know that those slides are there. We'll also send out a survey before that too. So yeah, that was a question. So any other question on that?
Yeah, Jack. This is Phil.
Hey, Phil.
Really interesting. From what you've gathered in your reading, does this split out the questions, the analysis on an urban versus rural community basis?
I can't completely confirm that, but I would from everything I've seen, I would expect so, because they are pretty robust, because they were even looking at you know, urban, suburban, semi-rural, and those type of things. So it does expand out, and it does look at things, you know, if you're out, because a lot of times, you know, in these larger cities, you know, there's a pretty extensive suburban and semi, someplace between suburban and rural areas, you know, surrounding them.
Great.
Another question? But I'll see if I can find that out too. They do offer enough flexibility on how they're doing these rules that I'd really be surprised if they can't do some of that. Does somebody else have a question? Nope. Okay, we'll go to the next one. This is from the similar groups of people. Jumped ahead on me here. Why did it do that? Bear with me. There we go. Okay, so this is a unmanned aerial system traffic management, and it's traffic management with obviously unmanned aerial systems to maintain, you know, safe and efficient UAS operations. Again, I mentioned Ames, NASA Ames, and if you don't know, NASA Ames is buried in the middle of Silicon Valley. And when I visited there, you could, you know, see the cars running around that are, you know, unmanned or automated cars and things like that are driving around. So, so they do tap into a lot of capability. As a matter of fact, if you look at some of these presentations on this one, there's one, and I think I can post that link because it's out on the public, in between NASA Ames and Uber, looking at these type of things. And so they're working with a lot of the folks around. And so so the last one was planning for where the vertiports and kind of the traffic and structure. This is actually managing the traffic as it's going on. And you know, and so they're somewhat complementary. They also developed through very much system engineering models, and this is evolving and adaptable and to set up to local needs, and it is set up to be in zones, or what I could kind of modular cellular, because you may have, say, if I'll use Houston because I live in Houston as a you know, example. So if you're down by the coast, you may have, you know, a UAS traffic that's working, that's going offshore to either the rigs or to the ships coming into port. Whereas, you know, you may have different type of traffic if you go out on the west and north side of Houston. There's a lot of these distribution centers up there. Of course, there's the port in the middle and stuff like that. So you can have different zones that are set up to manage traffic that's going on. Of course, that can be reflected back in the vertiport stuff, but this is set up to be able to do this. If you can look this up. So the FAA categorizes a number of different classes of airspace. And one of the things that drones operate in is Class G, which means there's really not a lot of control over it. But this is going to need, some of this is going to need to be adapted, and because you'll have a lot of traffic. The other thing, both of these technologies, and particularly this one, looks at, and that NASA Ames is looking at, not just for UAVs, but for aircraft in general, is the fact that the model of, you know, permission, and always asking permission and communicating positively between the, you know, the pilot and the control air traffic controller, whether will gradually saturate, and you need to have more automation in between. And these people are good experts on that, and they're looking at that for this these type of things. So
Hey, Jack, let me jump in here real quick. So
yeah, and Craig's been very active in that area.
This is more of a technical issue. So there's a lot of feedback, and it's coming from that owner account. I don't know if you have accounts running, so you need to mute that one because we can hear your feedback from your mic.
You copy that?
Can you hear me?
I can hear you.
It is muted now. I can see that the owner has muted here, himself or herself.
Yeah, it shows the owner account, which is, I think you had 2 running, and it's hearing your feedback from your mic. So you got to mute the other account, or it's gonna pick up your voice.
Yeah, I was trying to see if I can go off and do that, but now I've got myself. Okay. Sounds like it's died down. So the forecast is that, you know, as these things are approved, this traffic is going to drastically increase. And so it's going to need to be managed and organized and optimized as we go through things. There's going to be restrictions and boundaries, and some of those things are going to be dynamic, so you can't so it is I was trying to see, because I'm hearing that again. So as you know, if you have traffic, you know, and there's a you know, a school or something in the way, you need to, you know, establish boundaries. It can be dynamic, you know, readdressing these corridors and stuff like that based on weather and what's going on in timeframes and things like that. And so getting to be able to manage all that is the problem this is going to go look at. And so it could be tailored to the local needs and requirements. When you dig down in there, what I have here actually does not serve this justice enough, because there are so many different configurations and factors that can be added in here. And so you can it can be tailored and done fairly automatically to the local needs and requirements, the vehicle types. It's responsive to the traffic and what's going on. The nice thing about this is I talked about it being modular. You can separate providers. So if somebody was operating, a UTM system that has doing the airspace, say for example, on the south side of Houston in there on these things, it could be somebody different, but they could still interface up on the other side of Houston or the west side or something like that. There's it talks about dynamic geofencing, feeds for weather, and it's like I said, it's very, very feature rich. And so if you go look at this type of thing, keeping this developed, there's like software services, operational services if you wanted to set up to operate them themselves, or training if you had other people, or you could even have specialty on certain service types if you were just doing, type of offshore type things and stuff like that. This has a patent. There's the patent information. It was issued back about in June of 2019. It is adjusted a little bit to extend its the patent thing, so it is in effect for another 14 years or so, or is it? No, I'm sorry. Is that right? Yeah. Anyway, the inventor is I'm just going to call him PK because that's what he goes by. Craig has worked with him on some other things, and he's one of the prime researchers in this whole area. So there's a good collaboration activity, the opportunity there. And so part of it is being part of this research and seeing what's going on with things. That's always one of the prime advantages of licensing from a lab, is being in tune with the researchers. And when the researchers are this active in this area, it's great to be part of all that stuff and see what's going on. Like I said, if you're interested, you should look into a demo. And again, we'll post these up in there for contact information for that. It may be feedback from.
So Jack, you can go on to the owner. You can look at participants and find owner. I think it's probably just a one you're running, and you can kick them out of the Zoom or you can mute them. But yeah, it's hearing everything you're saying and feeding it back, so it's hard for us to hear.
Yeah.
Do you see under participants, and just, I think you can right click on them and mute them or something.
Yeah. Hold on just a second. Trying to get it opens the window down below. Whoops. There it is. Okay, I got him muted.
Yep, thank you.
Question?
Hold on just a second. So the next one here is it's a somewhat interesting one. It's got some potential, but it's probably very specialized. So I dig out, I find these things, and you look at them. So it's out of the Naval Postgraduate School. The nice thing is if you wanted to go visit them in Monterey, California, it's kind of a nice place to go visit. But it's how to identify foreign object debris on runways, taxiways, tarmacs, and they uses a swarm of drones. And I will get to some of, let's see. Whoops. I passed all of the, there it is. Okay, so basically it's pretty straightforward as you'd kind of expect. The nice thing about it is it's issued patent, so how they did this method is kind of protected and by the patent. So anyway, you can inspect a selected runway, taxiway, tarmac, using a kind of a line of drones with electric optical sensors that goes down, and they are calibrated using prior images and tells you when there's debris on there. That's kind of the way the technology. If you don't know, debris can cause damage to aircraft, engines, tires, and injury to aircraft personnel. There have been a few spectacular disasters because of those things. There was an SST in France, I believe, that had one. Manual inspection is slow, but the one thing about it is large airports already have implemented pretty elaborate real-time systems that scan the runway regularly, either with radar or electric optical or things like that. Visual detection is kind of not, it's too dynamic. It's not a real reliable type of thing. And recognizing that, it's not just big things that can destroy an aircraft. Small things cause damage. They can hurt people, but they also can, hurt a tire. Those tires are very, very hyperinflated. So if it blows that out. So basically a swarm of UAVs fly down the runway, do a set of images. The imagery is connected and processed through the software and compared. And you might be able to also collect this over time to view, the health of the runway structure too. So this probably is more applicable to lower traffic or smaller airports or medium airports. As I said, the big, there's two things with the big ones. They have implemented these pretty elaborate sensors that go down the runway and scan that. The other problem is some of the, if you're in Chicago O'Hare, you don't have time to fly these things very often because there's, there's one aircraft right after another taking off, and the other is probably the wake turbulence wouldn't let these things fly very precisely. So you need to have something with the lower traffic, but may not be able to afford such an extensive system. So it is a lower cost alternative. Let's see, there's issued patent on it. Let's see, that it was issued back earlier this year, and these folks are open to collaboration. A lot of the interface and the activity has been kind of prototyped, and there's some research papers. So it was prototyped in MATLAB and shows how it displays these type of things. And so that is that one. I don't know if anybody has any questions on that.
Well, I just have a background question.
Sure.
Why is it, I'm wondering why they chose a swarm technology as opposed to a single UAV?
That's a good question to ask them. I don't know. I kind of wondered that. I didn't get a good chance. The only thing, granted, this is speculation, but it's probably reasonable speculation is to probably get the granularity and precision that you need to look at, because sometimes you are looking for a nut or a bolt that's laying on the runway, right? And so that's what I would expect the answer to be, but that would be, if you're interested, that would be a good thing to ask them. How many do you actually need? And it may vary based on the width of the runway, because some runways are a lot wider than others.
And more quickly, as Sarah said. All right, thank you both.
See, I see something in there. Yeah, well, and that's true too, is based on the resolution, the Sarah, I guess you were asking her, using the swarm that lets you do it in one pass, right? And Terry, this was if you go look, the folks that kind of worked this, invented this, had a test case in a Singapore region airport that they had worked through, and there's a paper out on that. So and then for let's see, the last one, so this was interesting. It's a little bit, and it again, it's kind of straightforward, but it's a patent on it, and it does things. So it's a UAV based point, distance, and velocity measurement system. So it's for, and you say, okay, well, can I do that anyway? Well, part of it is the level of precision this system brings you, right? And it was developed. We'll cover it here in a minute. So, it's the bit is close counts and horseshoes and hand grenades type thing. They're trying to measure, and this is where the first problem was that they were looking at, is like our artillery accuracy, especially for training, so they could see how close things land to the target, score them, and then give feedback either on the system itself or the trainees or things like that, right? And so the traditional systems was labor intensive. So anyway, so this is an aerial platform based system that measures the distance, the ground points, and can analyze the speed. It can monitor velocities over a diversity of terrain, things like that. So pretty straightforward thing. So what it does is it also measures something without a GPS, or it needs a lot more a lot more precision than what that would give you, and movement. So again, I mentioned military munition accuracy and testing, sometimes law enforcement, forensic, but it was talked about, it could be in sports performance. So the cute one right off is somebody goes off and measures how far the javelin went. This could kind of do those type of things, but there may be other things as sometimes these things are enabling the fact that people don't measure something in a certain way because it is more extensive and difficult to do that. And whereas if you can do it easier, then people can find new solutions. Anyway, that's there. So basically, what's different here is the technology. It uses a UAV, but it has a ground-looking camera on its own stabilized platform to maintain a precise down-looking image. That stabilized platform is got an inertial measurement unit, if you know what that is, but it keeps you position and very stable platform as far as angles with respect to, say, the ground. And then it uses like a range finder to find the distance between where that camera is and the ground. So once you get that, you can use georeference data and to establish a field of view, and from that you can then measure the precise location and motion and score the measurements. What I would expect for a technology like this, and it may, what are the specific performance, that depends, and that probably is a bit of, it could be better and improved as you did more technology development and tested things out and understand how to do this better, or how you could apply this and develop your own technology to look at that. But which does make it, like I said, is the precision is the big thing here, but that's also a thing that you'd have to work through as you do the development. But it's a pretty straightforward problem. Again, it's for an artillery type situation or ballistic performance, mentioned law enforcement performance. There's could be some agricultural or conservation, if you're measuring where things are conservation wise. Infrastructure, I wondered whether or not, this is something that has to be explored and developed. Can it fill in for some surveying type applications, right? If you developed it. It is a pretty recently developed issued patent out to the Navy. They did bring up with nice collaboration with researchers available. You'd have to talk to them where their latest capabilities are. They did say that in the patent and the technology did say that a lot of the technology is the camera platform and how it's stabilized. It has to be hung straight under the UAV platform, but it did say there are a number of UAV platforms, and it was modular enough that a number of those could be used, the commercially available ones. And so let's see. Having said that, there's again the links going back to TechLink to they can help you with. They were on the last call we had about a month ago on how they can support you with technology and licensing type things. So, any questions on this?
There's one in the chat. Jack Joseph asked, any idea on the sort of range it can operate at?
I guess the clear answer is no. I would expect, from what I know, I'm a bit of a camera enthusiast too. It would also depend on your imaging and optics that you have hung under there. So if you had a pretty precise imager with some really good, lenses under there, and you get them calibrated right, it could be higher for an area. But one of the nice things they did say is, given that the platform hanging under the UAV is stabilized the way it is, the UAV itself could follow a pattern to a degree, and then while the system collects data and does its measurement too. So there's a piece of that is expandable, if that makes sense too. I don't know if that helped or not.
Phil, again, I have a question, but it's when you're ready to open this up, it's back on the UTM section.
any more questions on this one? And then we can go back. Okay. What you got, Phil?
I just wanted to, so it was on slide 7, I think, under technical maturity, and wondering where the issue of testing and certification would be reported. Can we glean anything at this level? So we're looking at a UTM product. I assume at some point these will require some form of regulatory certification or testing.
I would think so. And the nice thing, let's see, I'm trying to find the slide. Is it
7?
I went to 7. You went to 7. Are you talking about for the vertiport or for the UTM?
UTM.
Okay. I was looking at this. This starts at UTM starts at 9.
Oh, well, okay. I'm sorry. Bad information there.
Let's see, but I expect that those answers are that people in this
Yes.
research group is very much thinking about that, because they are also working with the FAA and a number of different groups. But yeah, it's a really good question. It raises the other side too, which is one of the things I thought of, is like indemnification if you took this type of thing on, right? Because how do you ensure that? But at the same time, insurance requirements may be built into their or plugged into as part of the rule set of their models, right?
I'll jump in real quick, Phil. So, what I'm hearing most recently is the FAA has a little bit of a challenge with trying to certify a UTM system, because this is not the way they think about things. Like what they'd rather certify is minimum requirements to operate a vehicle in said airspace. But like if you think about UTM, or you think about traffic management, the way it works now is, they spent decades figuring out how to certify aircraft, and then they spent quite a bit of time figuring out how to make sure those aircraft don't run into each other. And then you had all these pieces that got piled on top of that. It took decades before there was enough traffic to really create a traffic management system, right? And the traffic management system is not certified. It is all the pieces that operate in them are certified. The aircraft, the operators, the air traffic controllers, the airspace, like it's all certified in a way, but the traffic and there's software that tells the vehicles and the operators how they can move and how close or how far away they have to be. But the FAA never certified traffic management. So when you talk about UTM, the FAA is going to probably say, we're not going to oversee that. We're just going to tell you what certifications are required to operate in the system, and then private industry will determine, and we'll tell you like how close you can be and what environments, and like how you would operate in specific classes of airspace versus uncontrolled airspace. And then you guys got to figure out how you're going to do that to stay within the rules. So, and honestly, I think certifying UTM is not that high of a priority for FAA, right? That's like the scale that vehicles be operating, that they would need traffic management, other than like maybe some small areas, like that could be a decade away before it's really required, because there may only be like 2 drone if there's a last mile delivery, there may only be 2 companies operating, and one of them has market share and they're separating from their own aircraft because the FAA says you gotta make sure your own aircraft don't hit each other. That's on you. But as far as like all these different operators operating together and spacing them, I mean, that's years down the road before I think that's really an issue that folks are gonna have to deal with.
So short of a regulatory certification, a UTM vendor developer would still want to have be able to stand upon a pile of testing to demonstrate that they perform.
Yeah, well, yes, but they're going to be, they're going to be relying on the operators within UTM to be meeting FAA standards, right? So they're going to say, if we're creating a UTM, if we're taking UTM and we're bringing it to Oklahoma City and we're creating some UTM airspace, this is a provider that's doing it, they're not going to be certified, but they're going to be required just for legal reasons to make sure all the folks operating in it are following whatever requirements the FAA's laid out for type certification and, associated elements, what sensors they have on board. Those are all the things they're trying to work through. And so I don't think the UTM provider would be responsible other than to make sure that they say that they have met those requirements to operate in their system. So, but that's just my 2 cents. Who knows how it actually turned out. So.
Thank you so much. Excellent.
So the pilots would be, or the people operating would be certified pilots. The vehicles would reach some certification, so that there's some standard, and it's just not somebody that jumped up and
right.
There's a lot of the certification for, say, like the UAV type certification requires knowledge of what the rest of these systems in the context of the airspace and what they need to worry about and think about and stuff like that. So that helps create that awareness as they're operating, right?
Yeah. Well, so an example would be if you're getting in your airplane and you're flying to LAX during a busy push period or morning arrival period. Well, number one, you just wouldn't be able to do it. You have to get prior permission to do it. But let's say you had a citation, right? Private jet, you're flying in there. The FAA is not saying, well, in order to get in our traffic management system, we have to ensure that you're fully certified and that the system certified. They're saying it's on the company and the pilot to ensure that the pilot's certified, that the aircraft's been type certified. All of that stuff is on the company, and that the traffic management system welcomes that aircraft. And if they're not, and something happens, the liability is always on them, right? The company. So I expect that UTM companies will not want to take liability to ensure all of their operators are certified. That's on the operator, right? They're just going to ensure that that whatever spacing requirements the FAA is given or their operational requirements that they make that known, that's just the way it's going to work. So.
Yeah. And so, thank you, Craig. That's good input. And from the parts that I read, this UTM system helps maintain things like spacing. And it also, they did say it also can interface or interact with the stuff that is, say, differently controlled airspaces. So you can understand, in this region, maybe the spacing is this way, but then it changes, right? But they also throw up, these quote virtual walls where you say you can't cross past these areas. That's what you also have to watch out for, right?
Yeah. Thank you.
You're most welcome. Any other questions for today? Well, we thank you, everybody, for showing up to the event today. We will send you an email out that has links to the presentation and video and some of the other information, and including links to the contacts that were listed in here if you're further interested in the technologies. And you'll also get a survey. And so with that, I guess we will end this program.
Thanks, everybody.